Dear students, in the today's session, I am going to talk about the instantaneous center method. So we discussed about the Kennedy's theorem in the previous session. Now I am going to talk about the concept of the instantaneous centers. Right. So as we discussed in the previous session, instantaneous centers are mainly classified into three types in a mechanism. So there, first one is fixed instantaneous center, second one is permanent instantaneous center, and third one is neither fixed nor permanent instantaneous centers. These are the three types of instantaneous centers. So whenever we talk about the in a fixed instantaneous center in a mechanism, so whenever the two links are hinged joint, they are having the hinged joints, or when the two links are connected, so that will become a fixed instant center. That fixed instant centers are nothing but, so they doesn't change irrespective of the position of the links. So when one link is fixed and two links, if the two links are connected to the fixed link, if another two links are connected at the other two adjacent ends, naturally, so since the link is fixed, the centers are known as the fixed instantaneous center. The second category is the permanent instantaneous centers. In the case of the permanent instantaneous centers, they will be, depending upon the relative motion, they are going on changing their positions. Because in a mechanism or machine, whenever we talk about, so when there is a relative motion occur between the two links, automatically the other link also gets changed. Therefore, the permanent instantaneous centers are the centers where the position of the center goes on the changing. And third category is neither fixed or not permanent instantaneous centers. So these are the instantaneous centers we are going to find with the help of either the circle diagram or the circle method or the bookkeeping method that we are going to discuss. Now the first and foremost thing is that I am going to tell you what is the procedure. What is the procedure to locate the instantaneous centers in a mechanism and how to find the relative velocities. The first and foremost thing to locate, whenever we talk about the procedure, the first and foremost step to locate the instantaneous center is that the first one is, so first we have to draw the configuration diagram. We have to draw what? The configuration diagram we have to draw. So this configuration diagram we already know. It can be drawn to 1:1 scale, or it can be drawn to the reduced scale depending upon the length of the link. So after drawing the configuration diagram, the second step is that we have to find the number of instantaneous centers. That number of instantaneous centers. So this number of instantaneous centers can be calculated by, it depends on what? It depends on the value of the number of links. It depends on the value of number of links. If 4 links are there, or if I call n is the number of links, then the total number of instantaneous centers are n is equal to, capital N is equal to n into n minus 1 by 2. The formula is, we are going to make use of the capital N is equal to small n into n minus 1 by 2, where small n is what? The number of links, right? And of course capital N is the number of instantaneous centers. The third step is, very important step is, we are going to locate the instantaneous centers with the help of the circle method or bookkeeping method. What is the circle method? For example, if you just call, if number of links are 4, for example, the number of links are 4. The first what we do is, so we in the circle method, I am talking about what? The circle method to locate the instantaneous center. Locate the instantaneous, not locate, but to find out which are the instantaneous centers. So what we do is, first we draw a circle here, and I'll just put this number 1, this is the number 2, here it is number 3, and it is number 4. I will connect this 1 to 2, 2 to 3, right, 3 to 4 and 4 to 1. After connecting this, So this is the 1, 2, 3, 4. This link, this instantaneous center, I'll write as what is that? This is I12. This is I12, and this is I23. This is I34 instantaneous center. This is I14 instantaneous center. Right? So for example, if you just calculate this number of instantaneous centers, I am going to get the value of capital N is equal to 6, because 4 into 4 minus 1 by 2, which is 4 into 3 by 2, I am going to get the value of capital N is 6. That is, so this N is what? It is the total number of instantaneous center. So, but we have located 4 instantaneous center here. There is I12, I23, I34 and I14. So remaining instantaneous center is, for example, if you join here, this diagonal, this will be I13, and similarly, if you join this diagonal, so this is I24. This is I24. So like this, total we have 6 instantaneous centers. One is I12, I23, I34 and I14. Next one is joining this diagonal, it will be I13. Join this diagonal, it will be I24. So totally we have 6 instantaneous centers. So this is what this method is, we call it as a circle method. So in the circle method, the first step is what we do is, okay, I told you. So I draw the circle and located the points 1, 2, 3, 4, and so of course we have located. The second method is that, so we are calling it as a bookkeeping method. Second method is what we call it as a bookkeeping method. So in the bookkeeping method, what we do is we just write 1, 2, 3, 4. So this is 1 and 2 is I12, 2 and 3 is I23, 3 and 4 is I34. Next one is, so this is 1 and 3. I1 and 3 is, here it is I13. Next one is, here it is 2, 4, I24. Similarly, 1, 4, I14, I am going to write like this, right? So I12, I23, I34, then I13, I24 and I14. So this is what the bookkeeping method, this is what we call it as a circle method. Either you can just adopt this method or book method or bookkeeping method, no problem, whichever the method you follow, it doesn't matter, but ultimately we have to draw the we have to locate the instantaneous center. So after locating the instantaneous centers, so what the next step is, so depending upon the joints, we are going to locate the permanent or fixed instantaneous centers. Then afterwards, by using the Kennedy's theorem, we are going to find the instantaneous centers which are neither fixed nor permanent instantaneous center. So this is the method, right? So let me take a simple problem and try to find how to locate the instantaneous center, and at the same time how to find the angular velocity of the link. Okay, right. Now if you see this here, the problem is written here. In a pin joint 4-bar mechanism, as shown in the figure, AB is 150 millimeters, BC and CD are 180 millimeters, and AD is 300 millimeters. The angle BAD is 60 degrees. The crank AB rotates with uniformly at 100 rpm. We are supposed to find all the instantaneous centers and find the angular velocity of the link BC. Okay, let me write the given data. So you are that first link AB is having 150 millimeters, right? Then BC, which is equal to CD, which is equal to how much? 180 millimeters. Then AD is 300 millimeters. In fact, in this AD is fixed link. It is a fixed link. Now N is the crank. N is given as, so which is AB, which is equal to 100 rpm. It is given. Then so we have to locate all the instantaneous centers and find the angular velocity of the link BC. So after writing the given data, so what I am going to do is, I am going to draw as I told you, the first and foremost step is to draw the configuration diagram. Then we try to proceed further. Okay. So as I told you, the first and foremost step is to draw the configuration diagram with a suitable scale. Since we have to draw the configuration diagram, so ensure that sufficient space is there for at the top and left and the bottom, so that there should not be any problem for locating the instantaneous center. Okay. So link AD is fixed, it is 300 millimeters. So you can consider the scale, because 300 millimeters is 30 centimeters. So you can consider the scale as reduced scale, 2:1 you can consider, right? So if you just consider the reduced scale 2:1, so naturally maximum this will be, you are going to get as 15 centimeters. This is of course 9 centimeters. This is 150 means maybe around, no, this is okay, half of this is 9, this is 7.5, something like this. Okay. So configuration diagram, the first and foremost step is configuration diagram. So again it is I am drawing to the reduced scale, no problem. What I will do is just I will draw link. This is EAD, this is A, this is D, they are fixed, right? So I think in the previous problem, if you see theta is given as, I think you just read the problem. So theta is given as 60 degrees, that is, and BAD is given as 60 degrees. Therefore from B, that means from A, so you draw a line at 60 degrees, right? So you can locate this length as, this is 60 degrees here, 60 degrees here. Then the point B will come here, this is B. Then from B, what you can do is locate the point C, this is our point C, and join AD. Naturally AD is, it is 300 millimeters, AB is 150, BC is 180, CD is also 180, right? So after drawing this, the configuration diagram, right, the first step, then the second step is I am going to find out what are the number of instantaneous centers, right? So second step is N. So N is equal to, since there are 4 links are there, N into N minus 1 by 2, that is 4 into 4 minus 1 by 2, this is 6. That means we are having 6 instantaneous centers. That is the second step. The third step is, as I told you, we have to locate all the instantaneous centers, either circle method or bookkeeping method. So as I told you, so better one is a circle method. So draw a circle here. So this is 1, just draw the 4 links here, 1, 2, 3 and 4 here. So after locating this, as I told you, this is I12, I23, I34, here I14, join this diagonal, this is I24, join this diagonal, this is I13. So totally we have the 6 instantaneous centers. Okay. So after drawing these 6 instantaneous centers here, now I am going to locate. So naturally, so this is this is the link 1. I'll just call it as the link 1. This is the link 2. This is the link 3, and this is link 4. Right? So if you just locate the fixed instantaneous center. So this point is I12. This is I23. This is I34, and this is I14. And after locating this, remaining 2 instantaneous centers, if I want to locate, for example, I13 I want to locate. So I13, if you just see, so it is 1434. It is extension of 1434, 12 and 23. Where is 14? So it is 1434 and 1223. So 1434, 1223, right? So 1434 and 1223. So you extend 1434 here. You also extend this 1223, 1434. I am going to get as I13. This is. Similarly, if you want to get I24, I24 is 2 extension of 2334, right? 2334, and if you just see, that is 1412. It is 1412. So extend 1412 here, right? Then 1334. You extend this line. This point is I24. So how we are going to get this I13? Once again, I13 is the extension of 1434, 1223, right? 1434, 1223, I13. I24 is so if you just see 1214, 1214, 2334, 1214 and 2334. If you just extend this, we are going to get this instantaneous center. So like this we have located 1, 2, 3, 4, 5 and 6. Total 6 instantaneous centers we have located. Right? So I told you the circle method. You can just go and do also the book method also, that is bookkeeping method also you can do. The next step is we are going to find the angular velocity of the link BC. So this is of course this BC, angular velocity of the link BC we are supposed to find, right? But the crank speed is given. Crank speed is given. That means NB is given. When you just consider AB as the crank, NB is given. It is 100 RPM. So omega AB is equal to 2 pi n by 60. We know this. 2 pi n by 60. So that is 2 into pi into n is 100 divided by 60. The value, and just you can calculate the value. Again, you can just keep it aside. Right. And of course, I will take it later. Omega AB. So after calculating this, let me calculate the linear velocity of the link, omega AB or omega, because it is absolute velocity. So absolute velocity is the velocity with respect to the fixed point. Omega AB or omega VB, linear velocity is equal to, we know that R omega. So R is nothing but AB is the length of the link into omega AB. So if you just measure, we know that length of the link omega AB, that is the length of the link AB is 150 millimeters. If you convert in meters, it is 0.15 into omega AB is 2 pi into 100 divided by 60. The value we are going to get as, what is that? It is 1.571 meters per second. This is the linear velocity of the link AB or VB. VB, I am calling VB because it is the absolute velocity. So absolute velocity is nothing but it is the velocity of the point B with respect to a fixed point A. Therefore, VAB or VB is how much? 1.571 meters per second. If you just see the point B, this point B is also on the link BC. The point B is also linked on the link BC. Therefore, so we know that VB, when you just consider the point on the link BC, which is equal to omega BC into the BI13. That is from the Kennedy's theorem. BI13, omega BC into BI13, that is the length of the link. Okay, so if you just measure the link, this length BI13, so BI13 if you just measure, okay, so it is coming as 250 millimeters. So of course actually when you have just consider reduced scale, it is coming around 125 millimeters. If you convert into actual scale, it will be 250 millimeters. Therefore, from this, omega BC is equal to VB divided by BI13. So VB we already calculated. So VB is 1.571 meters per second divided by BA13 is 250 millimeters. If you convert in meters, it is 0.25 meters. The value is, we are going to get as 6.28 radians per second. This is how the velocity is calculated. So in this way we are going to do calculate the velocity analysis at the same time. So we just learn how to locate the instantaneous centers. So generally either you can follow the circle method or bookkeeping method to find the velocities, linear velocity or the angular velocity of the given links or given mechanism. Okay, thank you.